one. It's green, so you're more festive than I am.
It's the Irish day.
Right.
Beer comes along.
Oh, I really missed out.
My dad's birthday today, he's 100% Polish.
Oh.
I go to him and go, why aren't you wearing green? He goes, I'm not. He's colorblind.
All right, we're going to get started. So my name is David. Today I'm going to be presenting on from C# 6 to C# 7, then and now. So for the agenda, I'm going to just do like a little brief introduction of myself so you get to know how you can find me out in the community. We're going to do a little bit of celebrating Visual Studio 2017. We're going to do a review, just a brief review of C# 6. Is everyone kind of familiar with C# 6? Yeah, no? A couple, not quite as many hands. Okay, so I might spend not a ton of time on that, just kind of cruise through that. We're going to explore C# 7. That's going to be the bulk of the presentation. That's what you guys are all here to see, right? C# 7. You guys excited about that a little bit? Yeah. Okay. We're going to do some questions and answers and beer because it's St. Patrick's Day, and who doesn't like beer? Okay. So this is the introduction. This is, again, I'm David Pine. I'm a technical evangelist. I work for Centair, so I work in the consulting practice. I maintain a blog at davidpine.net. That's I got kind of knuckled into getting my own domain so I could be a hipster rather than just using the GitHub pages stuff. So that's, you can find me blogging about all things .NET, .NET Core, ASP.NET Core, Angular 2, TypeScript, and other things like imposter syndrome, because that's fun. Here's my GitHub. If you go to my GitHub, you'll be able to find the slide deck. Oh, actually, not the slide deck. You'll be able to find the open source project that I'm going to be sharing and demoing from, as well as other things. I'm active on Stack Overflow, answering questions. So I kind of set out to have like a personal goal to answer a question every single day. And if anyone use Stack Overflow here? Okay. Anyone answer questions on Stack Overflow? Yeah? Do you guys do one a day? It is hard. So that goal I failed at, right? You can't, it's really hard to do that. So I've been doing it just for over a year, and I'm like 260 some questions in, or maybe 300. So I've gained a bit of a reputation. So it's exactly. If you do that, yeah. Great. And then LinkedIn in case you want to hire me. So again, we're here to celebrate Visual Studio 2017. March 7th was the big day. That's when they announced the official launch of this great updated, shiny IDE. So who here has downloaded and installed and started playing with? Okay, cool. So what I did internally to Centair, who's familiar with Centair? You got some of us? Okay. So just real quick about Centair. Centair's got roughly 130 employees. We've got several different tiers. So for developers, I put a little poll out there, kind of inspired by some other ideas for the launch event. And 54 developers responded from Centair. And they stated the number of years that they've been using Visual Studio holistically. And we took the summation of that. So 510 years. That's a lot, right? To put that into perspective, let's do some math. The year is 1507. So time for a little trivia. That's actually when the Mona Lisa was completed, ironically, right? Because it's on par with Visual Studio IDE, right? So again, that's just us actively celebrating Visual Studio 2017. So let's just give Microsoft a round of applause for making our lives better. And then don't dance like that, unless you have too many beers, and it's probably fine. All right, so what we're going to do now is we're going to do the quick review of C# 6, some bullet points on some of the things that you may or may not be familiar with. It's kind of like a preface to talking about C# 7. So in terms of the features, there was 12 key features that were released as part of C# 6. We had read-only auto properties, auto property initializers, expression bodied function members, using static. I'm going to have examples of all these. So have you guys used all, like the ones that raise your hands for C#6 that you're familiar with it, who's actually used some of these new things? Okay. So the null-conditional operator is actually sometimes known as safe navigation, null coalescing, and the Elvis operator, which is actually really odd because it's actually a question mark and a dot, not a colon. So whoever thought of that should probably not have pictures posted on the internet like that. Right? And then we continue on with the feature set. We've got things for exception filters, name of expressions, which are really, really powerful. We'll talk about that one a little bit more. Await and catch and finally blocks. So the big kind of play on words there is you can finally await inside of a finally block. Yeah. Anyways, index initializers, extension methods for collection, indexers, and improved overload resolution. Some of these things we're not necessarily going to touch on. Just know that they're there and available to you. So the first one, read-only auto properties. So in previous versions of C#, before C#6, take the example on the left here. Imagine that we have a class that has a property that's assigned to from the constructor. Historically, you'd have this private set, right? If you're only assigning from the constructor, now that private set can be safely omitted. The place where you'd actually still want to use private set is if you're actually assigning to that variable outside the context of the constructor from within the class. Make sense? So auto property initializers. With this, we are able to kind of omit the construction, the constructor of the class altogether. We can, while we're declaring and defining our publicly accessible filters property here, we can actually assign to it with the equal statement. So we're able to say that, for example, in situations like this, imagine you instantiate the class and you instantly want to go off and access that property to check if it's empty. So rather than doing like null, is not null and empty, right, or any, you can now just do any safely, right? So you might want to provide that kind of functionality for your consumers of the class as a safety mechanism. So string interpolation, this is kind of cool. Does anyone see the discrepancy in these two statements? Good job, Lance. So this is one of the issues that actually existed with C# previous versions. We'll highlight that. So this, when you use string format, you basically assign the index for which the arguments will align, right? So since we're only saying 0, curly brace 0, only the first name is actually going to be printed out. And there's no way for the compiler to say, hey, this is an issue, you should figure that out, right? So now you can do this type of syntax where you preface the string literal statement with a $sign to indicate to the compiler that this is interpolation. So it's basically like a way to template strings. And then you following the similar syntax here, as you saw, you can actually access that variable. Very true statement. Because Java's awesome. Moving on. Expression body functions. So one of the cool things about C# that I've been liking a lot is it's moving towards becoming more and more expressive. So are you guys familiar with the lambda operator? Yeah, pretty well known. So now if you have simple statements like we're, public override string to string. So every object has toString, right? So if we override that virtual member, we specify our own functionality. That's been around forever. Now with C#6, you can actually define that as an expression. So you can omit the return statement, and the 2 curly braces and 3 lines of code turns into, if I was to format this differently, it could be 1 line of code. Yeah. But for the purpose of showing it on the screen, I made it 2 lines. And that's, again, the lambda operator. Null-conditional operators. So is everyone familiar with this example here? Like imagine that we have an event. And everyone knows that events require delegation. So in .NET, we have this thing known as multicast delegates. So that opens up an issue with the concern for potential concurrency and thread safety things. So the pattern has always been take a local variable of it because there's a potential for a race condition, rather than saying simply date changed and invoking the passing of that day. You're supposed to take a variable of it, check it to make sure that's not null, and then invoke it. Okay? So now we can do a null conditional operator on that specifically. And this is now the desired functionality. It actually does the same thing under the covers for you. So that's the preferred syntax for this nowadays. And at any point, if you guys have questions, like, let's make this more like a conversation, so I'm not just...
So on the previous one, I know that I use Interpolation.
Uh-huh.
They do a great job of telling me changes to the other one. I literally, I think I've learned a lot from having these hooked up. And I'm not noticing them in Visual Studio 2017. They do have some things converted, but not in Visual Studio.
So I am actually a really big fan of ReSharper. I've used it for many years now as part of my development tool chain. So one thing I will say is with 2017, I actually don't even have ReSharper installed. And a lot of the same, well, right, but
Unless you do something I
still don't have it installed, right? But one of the things is I've been finding is a lot of the keyboard shortcuts that I was familiar with that I would set up with ReSharper, and Microsoft kind of stole those ideas. Anyways, a lot of that stuff there, like, right, a lot of those core things that I would utilize are there now as part of 2017. So I don't know if I'm going to install it once it is available. It is for me, because I'm awesome. That one I'd have to look at. I don't know for sure or not. I don't know about that one specifically. I do know a lot of other ones. All right. So another feature was exception filters. So this introduced a new keyword, the when keyword, as part of the C# environment. So historically, if you were trying to achieve some functionality where you want to actually check whether or not an exception contains a specific message, this is terrible code anyways, but this is just an example, right? You can do other things with it. So imagine we are catching an HTTP request exception. We're validating whether or not it contains a 302, so a site moved in this situation. We could simply return a string that says, oh, the site's been moved. Otherwise, we would throw that original stack and exception, right? So now, with C#6, you can actually use the when, and this return statement is only ever captured when two things occur. One, it's an HTTP request exception, and the message contains that 302 string in it. And then you could return that. Otherwise, it's going to throw. Right, exactly. It doesn't catch it. So one, we're only going to, so with the catch statement as a general statement for C#, if this isn't just exception, we're already targeting a specific subclass of exception. So, and then when this Boolean value is evaluated to true. Yeah?
Do a chain multiples and just add the when, or are you adding one exception?
So the when it's a one-to-one relationship. So for each, the question was, if you have multiple catch statements, how do you apply a when statement to those, and whether or not they're chained? So the answer is, it's a one-to-one relationship. So for each catch statement of a specific type of exception, you can have, optionally, a when clause. And it applies only to that single catch. Well, okay. So another follow-up question was, can you chain whens? Can you have multiple whens on a single catch? The answer to that is no. It's a single when per single catch. And everything within inside this open and closed parens needs to become a Boolean. So this can be a function outside of here that you take a generic exception and do other things like logging or whatever it may be. So for each catch, you need to have, you can apply a when. So yeah, the question was basically, is the switch statement available in this type of syntax? The answer is no, you can't use a switch statement here. One approach that you could do alternatively is if you were to catch a generic exception, so the base just exception, and have a when filter that is a function. So imagine defining a private static bool handle exception, and you pass it that exception, then you could switch internally inside that functionality to do whatever you want, as long as that statement is to return true or false. Okay? So let's jump out and do a demo real quick here of C#6. Showing up okay. So some of the things that we had talked about, or I didn't necessarily show, was one of the things was the name of expression. So in C#6, we can do things, before C#6, imagine we had this throw helper that would just check whether or not something's null and then throw an argument null exception, right? That's kind of a standard pattern for validation of parameters into any type of functionality, a class constructor, or a method body. So in that event, it might be, you might want to use that verbatim string. So what if this name was to change and we change that? That exception might not be valuable anymore, right? So with the name of operator, we can, or name of expression rather, we can actually take the name of that and it's equivalent. So when this is compiled down, you're actually going to get this same verbatim constant string here instead. The nice thing is, if I'm to change it using refactoring tools, everything changes with it, right? Because it's known, it's part of that syntactical markup. Okay. So one of the cool things about that is you can actually define, like, imagine we have a private constant string for my name. And we know that my name, if I'm going to have a variable that's the same as the constant string, we can actually use name of to reference that variable. Since it's at compile time, it's a constant, right? So that's pretty powerful too. This is just demonstrating some of the string interpolation stuff, again, pointing to the different variables that are defined within this class. Don't know why I have that. Here is an expression bodied member. So this isn't only for methods. You can also do expression bodied members for properties as well. So we've got a private static double age and days, which just takes now less my date of birth. So I'm going to hide my date of birth so you guys don't make fun of me for my age. And then I take the total days. Oh. Dating others in the room. Let's see what else here. So one of the things that I wanted to demonstrate as part of this, I mentioned the static using. Has anyone used the static using? So with static using, one of the cool things is you can, everyone's familiar with the using statement as it exists prior to C#6, but with C#6 specifically, you can have this new static, it's reusing that static keyword. So you can say using static system.counsel. And we know that counsel exposes some static stuff already. So if I was to go counsel.writeLine, that's something that's publicly static and available to us, right? So now, in the context of this class, I can actually just go writeLine without that precursor. Same thing with string. Note this isn't the string keyword like the lowercase one, because that's really just an alias to the system.string. Same thing with math. So I'm using statically all these different things to have an output here of writeLine, checking whether or not this message is null or white space, using some string interpolation with the name of expression, and outputting this message, right?
So if a class has both static and non-static methods, if you declare the static, do you not
That's a good question. So the question, let me, I guess, try to rephrase that. So if the class exposes both public static and just public instance members. If we use it in a static expression up there, are we still able to instantiate it? Yes. Yes. There's no disadvantage to it whatsoever. There is one disadvantage, though, and it's readability. Sometimes people actually don't like this. They're like, where the heck did this come from? Another question? That's a great segue. So one of the things I did here was I defined this using static interesting custom console. Because if we make this static, now this is ambiguous. So now in the context of our application, right away, you get IntelliSense and you can't even compile the application because it's like, wait a second. What are all these static things you're trying to do? And it's problematic. Say that again? The question was, does that increase the size of your application? The answer is no. In fact, when you use static, when you define static functionality in C#, it actually compiles down to a less or a more compact version of IL for certain functionality. And it's a way to actually optimize certain things. So let's just jump back over to this. So one of the things that I mentioned was the ability to, well, first of all, who's familiar with async await and task-based, parallel? Okay. Perfect. So I've got this little joke functionality defined, and I instantiate an HTTP client. Does anything jump out to you guys real quick here? Does anyone know what HTTP client is a subclass of? Well, so the answer I was looking for is iDisposable. So one of the common patterns when you have an iDisposable is to wrap it conveniently in a using statement, right? So it does the proper dispose. So the reason I don't have that in a using statement here is because I wanted to demonstrate some of the async functionality for cleanup. Historically, prior to C#6, you couldn't use the await keywords within the context of a catch or a finally block. So now C#6 lets you do that. So now you can do cleanup in that regard if you're using some of the async APIs. I demonstrated the collection and index initializers here. So this is some new syntax. So for dictionaries specifically, we were able to instantiate them with the use of their index, right? So this is closer, this is really just a readability thing and bringing things closer to their actual usage. So if you instantiate a dictionary and you use that or you have that as part of your API, you might want to add a value to it. So you can always go .add, right? But sometimes people will take the advantage of doing the indexer. One of the advantages on a dictionary with an index assignment is that it does a get or an update based on whether or not that key already exists, right? So now when we instantiate them, we can instantiate them closer to the most common functionality for that object, right? So we have the square brackets here rather than, this is almost like legacy-esque. Right, yep. Demonstrating some of the null-conditional operators. I had already shown this. One of the things that was really interesting to me, though, about this is things start to get a little interesting in terms of evaluating those expressions. You really have to understand some of the stuff under the hood. So imagine we have this messages, which is just a list of strings. So if I do a null conditional operator on it to check whether or not there's any there, why do I have to put the true? You do. Because what happens is if that expression is null, it actually turns this into a nullable bool, right? So that's, you could wrap it in parentheses and then do .get value or default. Because again, even though any returns true, the expression to the right or to the left of that operand actually is returning a nullable. So it converts that entire statement into a nullable bool. So it's kind of interesting. You could. Yes, you absolutely could. So using null coalescing, you could say false. That's another thing. I don't know if I showed that. Okay. Yep. So let's just real quick run this because it's got a little C#6 application. This is the jokes thing, so we got a little bit of Chuck Norris, internet database humor there for nerdy people. You should totally steal that. And it's a random one every time, so it's pretty cool. If I run this multiple times, it's kind of cool. All right, so let's see. All right, we're going to jump back over to the slides. Now we're going to get into the fun stuff. C#7. So you guys just had a brief review of C#6. So how could C#7 be any better? Well, are you guys familiar with the internet meme Salt Bay? You guys know? Have you guys seen this? You've seen that? Salt Bay. All right. So he's some butcher, and he cuts up steak, and at the end of every little premium cut steak, he does this little thing where he like drops salt on it, right? And it's you've seen that? Okay, great. Don't ever grow up. So to me, C#7 is syntax sugar bay, because that's really what it is. Again, the language is so much more expressive now that it's just sprinkling syntax sugar all over the place, right? And so another thing I want to do here real quick as a preface to C#7 is to bring up this little debate that occurred. Thanks to Scott Addy here in the audience. How do you guys pronounce this? Let's just get a poll. Do you guys pronounce as tuple? Raise your hand. Tuple? Tuple? Okay. The verdict is in. I'm right. I call it tuple. But this is only out of 500 people, and there's... So I will refer to it as tuple. All right. So for C#7, some of the features that existed, or that are as part of the feature set for being delivered with Visual Studio 17, again, if you download and install this, you can have access to C#7 syntax and everything that's amazing with it. We get out variables. So a lot of people are like, what? That's already existed. We have out variables. I'll talk about this one a little bit more in depth. We have tuples, okay? Pattern matching, local functions, ref locals and returns, more expression bodied members. So now we can even do more expressiveness with the lambda operator. Throw expressions, generalized async return types, and numeric literal syntax improvements. This one's kind of, I almost omitted this one because it's not overly exciting. So this one's more just hands-on demo. So the rest of this talk is basically looking at C#7. So is there any questions before I jump into this? I'm going to. Yes, what? I'm going to cover tuples. Oh, I'm going to go over all of them in detail. Yep. Tuples. All right, let's jump back over here. Is everyone a fan of the new logo for Visual Studio? You guys like that? It's not much different, right? It's not really exciting. No. So, binary literals. This is the one I said that was almost we could admit because it's not terribly exciting, right? So we've always been able to do things, identifying a numeric literal as a hex, a decimal, an octal, or even using scientific notation, right? So that's been there for a long time. So now what they added is the ability to define binary literals. You preface the binary literal with 0b. That's indicating to the compiler that this is going to be binary. And then you can use an underscore to define. You can put the underscore literally anywhere. You're going to get obnoxious with it because it's valid. It's just there for syntax sugar to indicate like a logical separation betwixt sections of binary. Yep, exactly. Again, this one's not terribly exciting, but it is a feature that shipped as part of C#7 that is available to you today. Generalized async. So again, I asked this question before, who uses asynchronous programming? And if you do a lot of I/O, like network-bound I/O or file system or database stuff, it's very important to kind of understand some of the advantages of asynchronous programming as it applies to the benefits of throughput and defining, cleaner APIs in terms of core functionality, reusability, and things like that. So one of the things that existed before, obviously, is task. And you could say task or task of T. And also void is a valid return type with that. But with C#7, they've generalized it. So you can actually have more, you're able to kind of almost define your own. I haven't actually dived into that too much yet. They provide one for you, and it's the value task. So if you look at these two methods here, the value task, unlike task, if I hover over task, everyone knows that task is a class, okay? Value task, as the name would indicate, is a struct. You guys know the difference? Yep, yep. What about in terms of performance, or stack versus heap allocations? Yeah, this guy's with me here, even after eating all that stuff at lunch. Ugh. So one of the, repeat, oh, they didn't hear it. So one of the primary differences is in how memory is managed in terms of whether or not that memory is allocated on the stack versus the heap, right? Objects go on the heap, value types can go on the stack, but not always, depending on how the stuff is done, right? So one of the advantages with the value task is if this, some value async here, if the value is immediately known already, that we're going to return 0, for example, if the numbers doesn't have any and we return this, rather than newing up a class object as part of that task return from the task.from result, and rather than taking on that extra allocation and that memory impact, we can just return the value task that will represent that a lot more lightweight. So you're not instantiating this object, instead you're returning a value. So it actually makes it more performant. So I have an actual demonstration of that. Once we run the app, we'll get to see running 5,000 iterations of one versus the other and the time discrepancy. It's nearly double, as a spoiler alert. All right, so local functions. With local functions, a lot of times people are like, when they first see the local function syntax, they're like, why did the language designers decide to do this? And I was one of those. I was guilty of that. I was like, this is terrible. I'm never going to use this. Why would I use this? So it actually turns out that there's a ton of advantages. So everyone's familiar with IEnumerable, right? So we're entering into the world of deferred execution. When we have this yield return, that actually turns this entire function, or this method body, into an iterator. So when this is evaluated, when someone says local functions dot alphabet subset, who here knows what happens? Anyone? The correct answer is nothing. They get returned that iterator, but even if they give us invalid arguments, that's not going to be thrown right away because it's not evaluated until that enumeration is iterated. So unless they call toList, toArray, or they do it in a for each, that error is not going to occur. So ideally what you like to do in C# is fail fast. So if someone gives us some invalid arguments, you might want to rewrite this method like this, where you separate the actual iterator block from the validation, right? Anyone see an issue with that? Exactly. Very, very correct. We have two functions. In terms of reading this class now, whoever comes in here and looks at this code, now they have to be aware. Oh, there's this other functionality somewhere. So they have to go potentially looking for this class. They have to be concerned with, is anyone else using this? If so, why? you have to know more about the class than you really need to. Ideally, you want to go into that function, isolate your concerns, and say the validation and the iterator block, these two things are logically, cohesive. So they should belong together. This solves the issue of getting immediate validation and failing fast, but enter local functions. So the new syntax for local functions allows us to get the best of both worlds. We've defined a function within this method, and it's local to this method. This alphabet subset impl is not available to anyone else inside the class. And it's a very, very simple iterator. It supports generics. It supports asynchronous programming. It supports recursion. It supports a lot of things. Also note that it's defined after the return statement. It's kind of neat, right? So you can actually nest local functions. It's probably a code smell, though, if you have like 15 local functions that are nested, right? Again, this is just demonstrating that you can do it also with task returning things, and then even delegating out to other work, formatting. So this is probably a terrible example of what not to do. I've got another one that's even more obnoxious that you would never want to do. Probably slap someone if they tried to do that. Yes? The question was, can you unit test the local function? The answer is indirectly. So yes, but it's kind of like the same way you would test the other scenario, where you test the validation, you have some test cases for that, and then you test the actual iteration. So again, given certain inputs, you get certain output, whether it be an exception, whether it be an iteration of the correct result you were looking for. So indirectly, yes. Right, exactly. Yes? The question was, does a local function have to be after the return statement? The answer is no. It can be defined anywhere. So one of the biggest complaints about this type of syntax is people, when they read it, they think to themselves, this method is really starting to turn into a class, right? Because it can get kind of large. Typically, you want to try to nip that in the butt and isolate concerns to make it more logically cohesive. But you can, again, you can define local functions anywhere within the body of the method. So there was a comparison that is, I think, kind of pertinent for understanding local functions. A lot of times people look at local functions and they're initially, the first thing they think of is, I can use action or a func here, right? I can define a lambda expression. So why would I need this local function? Again, with local functions, it supports generics, it supports iterators, it supports recursion. It's not this new word here, allocati. Anyone heard this? Yeah? David Fowler coined this. He's like a tech lead at Microsoft. He's poking fun at people that incorrectly allocate things that are unnecessary with lambdas. So it becomes allocati. So there's a lot more heap allocations. When you define a function like this delegation is actually on the heap because that delegation is an object, whereas instead we're just expressing functionality with a local function. So it's a lot lighter weight. Okay? So again, there's no declaration either with local functions because you're not actually declaring something in memory. You're just expressing how to function. And this is the example of don't ever do this. So let's just read this real quick. We've got an internal static async task that says don't ever do this. We're getting a result, which is obviously a string. We're building a string out. And the parameters to the string is params character array. Great. We've got some async APIs. We're using binary literals, null because we can, hex because why not, character space for whatever reason, and we're going to write out that result. And then here's how we're handling that. We're doing, this right here is a little bit of pattern matching. I got a better example of that later on. So I'm just going to say, when I run this application, look for what all this spits out. So moving on to expression bodied members. Yep. Right.
But if you declare the variable and it's coming up with something like here, you've got to make sure that you declare the variable before you actually the function. And that's the only time in base that you actually do consideration where
Yep, that's a good point. Likewise, with nesting of local functions, so imagine we have a method body, that's standard method body that's publicly accessible, and someone invokes that. We have internally a local function within there, and imagine again we've got another local function that that grandchild or child nested local function is not accessible outside the context of that the parent local function scope. So more expression-bodied members. So as I mentioned with C#6, you're able to do that on functions and properties. Now, with C#7, they expanded that. So again, we're getting even more expressive. So we can do that on constructors, finalizers, and get and set accessors on properties and indexers. So let's take a look at what that looks like. So imagine we've got a class. We've got two fields. We've got the constructor for that class. We can define that simple constructor logic with an expression, with a lambda operator to specify, rather than, again, having parens and making like a standard syntax, you can do it this way. This is only applicable for, like, again, really simple constructors. Same thing with finalizers, again, showing how you would express that. Likewise with the get and set. So now rather than saying, get open and close parens, return underscore label, we can just say get, evaluate this expression. Okay. And this one's actually using the throw expression here. So throw expressions is, again, another feature of C#7. And what this allows us to do is we can, let me just jump over to that example specifically. We can actually safeguard functionality as we see fit. So imagine that we have a list. We can define a subclass of a list of T where T is a class. And we can specify that that class, we'll just call it a safe set list, right? So people that want to use the indexer on that and set the value, if they try to assign the value using the indexer to null, we can coalesce and use this throw null reference exception stuff here. So this is a throw expression. So the statement is we're going to set the base index equal to the value passed in from the indexer assignment. If that value evaluates to null, we're going to coalesce over to a throw. So if anyone tries setting this to null, we're going to throw an exception. Cool. So that pattern is really, really powerful. A lot of times with dependency injection, if you're like using .NET Core or ASP.NET Core or any type of other .NET stuff where dependency injection, where you're using like constructor injection, one of the common patterns is to kind of ensure the state of your object, right? So if you're getting something constructed, passed into you as your constructor, you want to validate those arguments so that you can easily verify, again, fail fast. So imagine we've got a legacy service here that's taking on an iContext provider. One of the common patterns is to say whether or not it's null. And if it is, throw. Else assign and continue on with life. Now that turns into a single line. 2 here, for example. But really, it's just a single line. It's equivalent to the stuff happening above in that we will coalesce over to the throw expression in the event of that assignment being null. Make sense? Cool. So out variables. This is the fun one. Well, this is actually, there's a couple other fun ones here too. This is pretty fun. So the legacy try pattern. Who does this? Who uses try, like int.try parse and all that stuff? Okay. So it's been a kind of painful, right, to have this function that defines. I'm going to give you a bool to let you know if whether or not the out variable that you're declaring above me is valid or not. It's kind of insanity, really, because it makes your code ugly, in my opinion. But that's just my opinion. So anyways, I was available to us. So if we define, or if we declare an int I and we evaluate that against this if statement, so int.try parse with the number that was passed in, if we parsed it and it is an int, we can do stuff with it, else just return something. And again, I is available in this context or in this scope. So the new pattern is to remove that declaration of int altogether. It's not necessary anymore. With C#7, you can use this like inline syntax here where we say out variable. This could be int too, right? So we're actually allowed to use the var keyword now. So imagine if we had like a dictionary, right? So, well, dictionaries probably don't have try parse, but if you were trying to do something crazy, those types can get really, really big. So who doesn't like using var? I say var all the things. So does anyone know, without, well, I'll probably already spoil it. I is still available in the same scope. So I actually leaks to the outer block of that if. So that I variable is still available, even in the context outside the if else. So it's available to us here, as we'd expect. Even here, we know it'd be 0 since it's an int. And since ints are structs, and structs always have a default type, default or value, so an int would be 0. Otherwise, again, we can still use it out here. So. Right. Yeah. So again, you can be explicit. Nope. Yeah, it can't be outstring. That will fail. That'll give you. Yep. Yes, you can. So some other cool stuff is talking about some of the scope again, proving that it only leaks to the outer scope of the if in which it was initially declared. So date is only available here, but the time span is only available within the context of this body. I can't access TS here. And to Lance's point, if you really, really want to get expressive, like I have done here, imagine defining some extension methods. Who does extension methods? Love extension methods. I'm terrible when it comes to C# because I go nuts sometimes. So imagine we've got strings, right? Everyone knows strings. We use them all the time. So a common thing might be to parse those out. So imagine a way to kind of compact all that core functionality into a little compact bit of information. So we've got the string extensions class. I'm defining a private delegate of bool. Try parse delegate takes a t. It's given a string, and it outs a t result. We've got this generic private static t to t, given the string, with that try parse delegate. And we're going to parse it out. Since it's in line, right, we're going to say out t result, the result, or default t. So now we can use that and say internal static int to int 32 on the string, and that's using try parse. So there's no exceptions. You can walk up to any string and say, are you an int? If you are, great, I got it. If not, you get 0. Move on with life. And then you can encapsulate all that logic and do it with date, time, and IP address, and time span, and so on and so forth. So really, really compact. Cool. So pattern matching. I don't see much more time with that. Okay. All right, pattern matching. So pattern matching introduces this notion of patterns, where we can look at the state of an object and we can reason about it. So one of the things that's available to us is this constant pattern, where we can check if things are null, or we can say is int or is date time, and it looks at that that object and reasons about it. And then likewise, you can combine that functionality with a declaration. So imagine a situation where we have that same object and we want to test if it's an int. When we're testing if it's an int, we can also declare that variable in that scope. So if object is int I, now I have access to I. And I is an int, and I has already been converted over to its type for us. So I is now in the scope and an int. So we can do stuff like that. Again, I leaks out to this scope, so it's available to us. Any questions about that real quick? No? Absolutely, yeah. So one of the things here that it does is it really combines, it's kind of mixing metaphors is the way I like to put it. So historically with C#, we could say object is type. And we could value about that. You know, we get a bool back and say, is it this type? And then we would go cast it, right? So now we can do that in conjunction with what looks like a declaration. So type assertion plus, so this is really like in my opinion, a compound expression. Object is int I, right? So object is int, type assertion, int I is declaration. So now we have I. Yep. Yep. There's been no changes in terms of the as keyword. As keyword still works the same as it did. Let's see here. This example really just talks about how we can reuse this declaration of int I, right? So note that we say if object is int I, or if this object is actually a string, then we can invoke our try parse on that string and out it. We're reusing that I declaration. So if we move this statement to the left operand of this evaluation, we'll get a compilation error because I hasn't been defined. Okay? So that's pretty neat. So where things get powerful, this was the is stuff. Now we can actually do switch. People asked about switch statements. Yep, yep. Because really that declaration occurs here. That's a good question. Let's try that out. The question was, do we get duplicate declaration errors? Yes, because int I is already declared. Okay, cool. So imagine we've got a shape class. We've got two properties, height and length. We've got a constructor that takes on both of those property assignments as arguments. We've got subclass circle that defines a radius, diameter, circumference. We got a rectangle defines further functionality to a bool that says whether or not it's a square. So pretty simple, right? Object polymorphism, inheritance, all common stuff you guys are familiar with. So imagine that we have a function that takes the base shape, and we want to reason about that. So now the switch statement has been generalized such that we can use that. Again, this is, I mentioned before with the catch expressions, or we can actually use that new keyword when to do more stuff and reason about it. So we can say case when the shape is a circle, C. So now we can reason about that shape and declare it. So this will evaluate if the shape we're enumerating is a circle. If it's a rectangle and it's also a square, we'll evaluate this line. If it's a rectangle that's not a square, we'll evaluate this line. Otherwise, we don't know what's going on in the world because we have no shapes. And then we can even case on null because that's a constant, right? Beautiful, right? Exactly, yep. So the question was, what would happen if the shape that we're switching on was null and we don't define the case null? The answer is that it would go, I believe, to the default. I actually haven't tried that, though. Right. But since this isn't really under the covers, this is just an is expression, so a type assertion, I'm assuming. So if it doesn't fall into any of these logical Bool expressions, it's going to go to the default. So we could try that if we have time. So that's pattern matching. One thing is ref locals and returns. This is where things kind of get interesting. Actually, I'll do this one next because this has got some tuple usage. Let's go to tuples first. Tuples. Tuples, not tuples. Anyways, legacy tuples, they actually had this type, right? And again, this goes back to the whole holistic view of being less alicati. I think, anyone know, this is a class, right? I think so. I don't think it's a struct. I don't know for sure. Let's not Google that. Anyways, so we could define tuples as we saw fit, take ambiguous types, and basically one of the advantages to tuples is you can invoke equality stuff on it, because the hash code was unique in that it just takes the two items that are there and runs a hash code against those. So with C#7, we've got value tuple. And value tuple has some kind of interesting syntax. So we're basically able to snip away the entire instantiation of the tuple with the type declarations. Note here, rather than doing strings, I did characters just to be a hipster. So now we've got letters in our value tuple. So note that because of that, we actually have letters gives us this items 1 and item 2. But notice that syntax, or the IntelliSense rather, doesn't give us anything else. We have this 2-tuple extension method, which would give us the legacy version. But that's not really helpful right now. So again, yeah, we can do that there to get the system tuple. So another way to define this, well, that's just another example of defining different types. So now we can define tuples with a property name. So does anyone know what happens here? You actually end up with a word and number tuple that actually hides item 1 and item 2. So IntelliSense is smart enough to reason about the stuff that was there before, thanks to Roslyn and real-time code analysis. It's smart enough to know that, oh, you've declared property names for these tuples. Okay? So that's pretty powerful. So there's this notion of deconstruction. So with deconstruction, we can take that tuple and assign it as we see fit. So we could take the string and the number, defining their types if we want. We can use var, because that's everyone's favorite keyword in C# nowadays. Again, taking the string and the number 1. Or we could define it as var without the types there at all. So deconstruction is pretty powerful too. So we can basically take that tuple, if it's even in a function return, and we can utilize it as we see fit, deconstructing it. This would all evaluate the true because these are all equal. Yeah, like this one here you're saying, or? So you want to say like string 1, for example? Probably likely. It does know the types. These are all known. Yep. So string 1, for example, we know is a string. String 2 is a string. Yep. Again, more kind of shorthand, just another example of how you can do things in now and 10 seconds, taking datetime now and a timestamp from 10 seconds. Really compact kind of. Say that again? Oh. Yes. That's a good question. I haven't demonstrated that and I haven't explored it. Right. Yeah. I'll have to look into that because I'm curious now. So here's a name tuple assignment example. We can actually do anonymous objects. Real quick trivia for everyone in the room. Anonymous object in C# is immutable, right? Yeah, waiting for heads to shake with me. Does anyone know what type an anonymous object is? Is it a value type or a reference type? Value type? It's immutable? No? Yeah? It's actually a reference type. I didn't know that. I learned that just the other day. So we had defined property number 3 as a new pizza yummy, because that's what we had for lunch. And now we actually have access from that tuple property into the anonymous object. Crazy, right? We can actually use tuples as returns as well. So imagine we have got this range functionality where we take an IEnumerable of int. We've got some numbers. We do a little bit of common functionality, and we return that, the min and the max. We can compact that and use generics if we want, right? We can do tmin, tmax, and a range of IEnumerable of t, and just call into their generics. Why not? So then if we had the ones for ints, that obviously would work this way, but if we, again, have our, this is redundant. Look at Visual Studio lighting up. We can remove that. Simplified name range. But it's a decimal, and it knows it's a decimal because we define that here. In fact, if we just get this as a var, we can remove the declarations altogether, and min and max are still decimals because they're defined as so here. Okay? Now, an interesting thing, we've talked about returning them and using them and whatnot, but one of the things is you can actually use them as arguments into your objects. So imagine we've got a person that's defined as, it's got this name property. Name is really complexing, so you might have a first and a last part. So you can actually take that as a tuple now and assign that name property. And when it's instantiated with David Pine, for example, in my age, you can access the first and last part of that name. Cool? Okay, I'm actually at my time box, right? I've got one last example. Lance is up next, so he's saying he wants here. So this is the last example. I'll try to go through this quickly to respect everyone's time. So ref, locals, everyone's familiar with the ref keyword, similar to out, right? So you can take a reference, almost like a pointer to a variable. So now, imagine that we've got this find functionality. We've got a matrix, and we've got a predicate here that we're going to use as part of our evaluation of this iteration. So once we find what we're looking for, we can return that tuple, right? So that's great. It gives us I and j. So if we had that matrix, we could walk up to that matrix, find what we're looking for, and then kind of reason about it and do things with it, which is terrible, because if we wanted to assign it, we'd have to do this nonsense, where we go find it, and then we have I and j, so we have to walk out to that matrix and do all that stuff to it again. Well, now with reference returns, we can actually say we're going to return a reference to that integer. So basically, this is a pointer into that matrix. Anyone with me on that one? So now what we can do is we can say ref, find by reference, ref variable item, and now we can say item equals 777. So that's actually assigning those two indexes, I and j, that a variable, or that value. That one takes a little bit to kind of wrap your head around. But really, it's just a reference back to those indexes. Cool? So let's just run this one real quick here. So this is the difference between the task and the value task in terms of, oh, that's a terrible run. Usually it's a lot more than that. One thing, though, that you will notice that the task always takes longer because there's more allocations. Typically, it's twice as long with most of my stuff at home testing. This is not really a relevant example. Okay, this is that crazy what, don't ever do this. It simply says hello world. That's all it spits out. All those crazy binary literals for no reason at all, and characters and nulls and stuff. And then this is just the assignment into the matrices, showing that once we assign it, that's the variable it spits out. So that's it. That's all I had. So if there's any questions, hit me up afterwards. Thank you very much. And you can get the source for all this stuff that I put together right out there.